All right, so Esther, now in the previous parts of alcohols and carboxylic acids, we do understand that all alcohols, carboxylic acids, and esters are organic compounds, and they are made up of carbon, hydrogen, and oxygen, as we know from their formula as well. Now they're closely related, and actually esters are something that are made up of carboxylic acid and alcohol themselves. Esters are frequently used for perfumes and artificial flavors being on the top of the list, since most of the natural flavors are actually esters themselves. For example, the flavors that we commonly see in children's stuff like the candies or the ice creams, or all those flavors are actually esters. Name of fruit, the flavor actually comes because of the chemical being an ester. So yeah, for example, mango flavor, apple flavor, banana, chocolate, vanilla. Actually, they're all esters. When I say the word flavor, I'm actually including both the smell, or you can call odor, right? And I'm also adding the taste to it. So when I use the third flavor, I mean both of it, right? So moving on. Esters are actually organic compounds, and the reaction is of alcohol and a carboxylic acid. Now, this is the functional group like this. Now, if you look at this functional group, you'd come to see that the previous functional groups only had one connection, right? For example, alcohol had one connection, a single one on just one side. Carboxylic acid had one connection, a single bond just on one side. Esters are the first group that actually sticks to the center and can be connected from both ends. So they have a single bond on one end as well as on the other. So what do? We write them as COO in condensed form, right? That's its functional group. And remember, the carbon chain may continue at this end, on the left end, as well as it may continue on the right end. So let's move on to the next page and start learning how to make esters. Now, we're not learning their naming and structures before any of their formation techniques. Why? We're doing that since the naming technique and the formulations are going to largely depend upon how they're made. So it's really good if you understand how they're made first and their structures and naming techniques after. So we're going to start making a simple ester, that is ethyl ethanoate. Now, it has quite a strong smell. It can be used in solvents as in nail polish and nail polish removers. So how do we make it? We're going to take ethanoic acid, which we commonly also known as acetic acid or vinegar, the one we studied in the previous chapter. We're going to take the ethanol, the alcohol that is famous for drinking purposes, and we're going to form the ethyl ethanoate, our ester, and along with that, some water. How are we going to do that? We're going to heat a mixture of ethanoic acid and ethanol together, and we're going to add a few drops of concentrated sulfuric acid. This concentrated sulfuric acid is actually going to behave as a catalyst. So the purpose of this concentrated sulfuric acid is to speed up the whole reaction. All right. So starting materials, this and this. This one is a catalyst, and the conditions is heat. These three things are a part of past paper questions. So that's why they have written them in such a way so that you'd know whenever they ask about the starting materials or the catalyst or the conditions, you can always tell them those answers separately. Now, concentrated sulfuric acid isn't written into the equation because it is a catalyst and it is not consumed in a reaction. Remember, what is a catalyst? A catalyst is a chemical that can speed up the entire reaction, but it is not consumed by the end of the reaction, right? So we know it's not going to consume, so we don't make it a part of the equation. Then take a look at the equation. You're going to find a reversible equation in there, right? This is the symbol of a reversible reaction. This is a symbol of irreversible reaction. So yeah, this means that the reaction may proceed forward or may as well proceed backwards. Okay, we're going to study how we're going to take it into forward direction a little later in the same part of the chapter. Now, this reaction is called esterification. It can also be described as a condensation reaction. Why can we describe it as a condensation reaction? Because water is made when two molecules are joined together. And in the next chapter, we're going to call these specific kind of reactions in which we mix two things up, we form a product, and along with the product, we specifically make water. We're going to call them as condensation reactions. All right. So esterification itself is a type of condensation reaction. Condensation reactions are discussed in a very last chapter of this book, which is, by the way, next chapter, the chapter right after this one. And we're going to discuss how water is made in a reaction when two molecules are joined together. We're going to discuss the same thing when we're going to draw the esters in the very next topic. So the reaction is reversible. To maximize the yield, what do? We use pure ethanol and we use pure ethanoic acid. Pure ethanoic acid has a specific name. It is known as glacial ethanoic acid. So in chapter number 21, we discussed how the position of equilibrium shifts to counteract any changes that we make. So if you add water to the reactant, the shift system will actually shift towards its left. It's going to go backwards to consume the water. Therefore, decrease the amount of any ethyl ethanoate that you make. So what do? We use pure substances and we never use water along with them. Although both of them, both ethanoic acid and ethanol, are soluble in water, but you'd notice clearly that we have used their liquid forms and not their aqueous forms. Since if there is more water in the system, we will end up having too much water because it also produces water as a part of the product, and that is going to take the whole reaction in backwards direction, since it's a reversible reaction. This part is specifically connected to physical chemistry, which is unit 3 of the book. If you have studied that part, you definitely understand what I just said. If you haven't, don't worry, you're going to study it a little later. Because I know some schools do cover unit 4 before they cover unit 3. So I'm not sure about you. If that happens, don't worry. This paragraph can always be understood after you're done with chapter 21 from unit 3. Now we're going to move on and try drawing and naming esters. Now, since we know how to do the whole thing, how they are formed, we can always practice this for now. Now, what I'm going to do is that I am going to teach this whole part on a separate whiteboard. I'm going to transform this entire diagram into 3 specific steps. That way, the formation of ester is going to be extremely easy for you, as well as the drawing. And lastly, you'd also know how to name it. So I'm going to stop right here and let's open up a whiteboard. Just give me a quick minute to do that. All right, let me share my whiteboard with you. That's good enough. Okay, so what I'm going to do is that I'm going to divide this whole part into 2 sections. We are going to study the drawing over here, and I am going to convert that whole diagram that you just previously saw in your book into 3 simple parts. I'm going to do the same with naming, but we are going to start the drawing part first, and then we're going to do the naming after. Okay, for drawing, there are 3 simple steps, right? Acid first and alcohol after. That's the first thing. So we're going to always, and by write, I exactly mean draw. We're going to always draw the acid first and the alcohols after. So in this case, we were supposed to start with ethanoic acid. So what I'm going to do is that I'm going to draw the acid so that I can explain my point. So the first point being, we write the acid first, we write the alcohol after. So the whole acid structure is something like this. This is our acid, ethanoic acid. And this is our alcohol. Our alcohol was supposed to be ethanol. So here's the structure for ethanol. This is your first step. All right. As easy as it may seem, you just got to remember the whole order: acid first, alcohol after. Number two, write the alcohol sideways inverted. So what are we going to do? We're going to invert the whole alcohol sideways, which means the left of it becomes the right and the right of it becomes the left. All right. How is it I'm going to do that? I'm going to explain the whole thing by drawing. So this is our acid. I'm going to write it in a similar way. We're not going to do anything to the acid, but I'm going to change the whole alcohol. Now, this H comes first. The right becomes the left. Then comes the O. Then comes the C with 2 hydrogen. And then comes the C with 3 hydrogen. So I inverted the whole alcohol, as you can see. All right. And third and last step, what we're going to do is that, and I'm going to, take this one out. So we're going to take the whole H and OH part, and this forms water. You're always going to take hydrogen out of the alcohol and an entire OH out of the acid, and that's how you're going to form water. What are you going to do with in third part is pretty simple. So take out water, which we already did, and combine the rest of the structure. So the whole thing becomes C. Now, from this part onwards, we write this one. So that becomes O, then CH, and I have a little less space at the bottom, so I'm gonna write it in this way. So there you go. You have already combined the rest of the part, and that's your ester. There you go. If you follow these 3 simple steps, you're always gonna end up having the correct structure of the ester. In your book, the only difference is that they write the alcohol first and the acid after, and they actually invert the whole acid thing. Even if you do that, it's going to be the same. Remember to take always H out of the alcohol and OH, entire OH group, out of the acid and form water out of it. As far as the naming part is concerned, first things first, acid ends in enoic acid. Alcohol ends in enoate, sorry, not enoate, no, all right. So alcohol is changed to from anol to aryl. Acid is changed to from enoic acid to enoate. So it's pretty simple. Third and last rule, always write alcohol part first, and acid after. So it becomes from ethanoic acid. Sorry, no. Actually, we were supposed to start with ethanol. So I'm going to rewrite the whole thing. Ethanol to ethyl, and then ethanoic acid to ethanoate. That's it. 3 steps for naming and 3 for drawing. You're always going to end up in correct structure as well as the correct name. All right, let's give it a quick revision. So you always draw the acid first and the alcohol after. Then you invert the entire alcohol sideways. Write the right part first, and you convert them into left, and you can write the left parts after, and they're automatically converted into right. All right, and you're gonna take H out of the alcohol, OH out of the acid, and you're gonna combine the rest. You're gonna get your ester. Remember, when you're combining this part, don't forget that this functional group comes in the center, COOH, that we started the whole chapter off with, right? Now, something you already know, most of the acids end in the word anoic acid, and the alcohols end in the word ano. So what do? We change the anol to il, and we change the anoic acid to enoate. So ethanoic acid becomes ethanoate, and ethanol becomes ethyl. That's how we change things. Now, you know, even if you don't have the structure, you have just the name, you can write the name of the ester. And if you have the structures as well, you can definitely convert it into this form. Make sense? Are we clear? Okay, good. Aisha's clear. What about you, Darshan?
Yes, it's clear.
Okay, good. Good. So, I guess we can always move on and try a few examples. I'm going to take a picture of this one. Just a second. All right. And let's go with just a second. So I'm going to add another page to the whole thing. And that way we can practice it. So it's always up to you whether you'd like to practice on it on a piece of paper and then send the image to me on WhatsApp, or you'd like to simply annotate on my screen. It's entirely up to you. Right? So I'm gonna quickly add on a new whiteboard in its practice. So I'm gonna name that as Esters practice. That's it. So let's begin. What if I gave you different esters? Actually, different reactants. So can you try forming the whole structure of an ester along with its name? So let's say we started off with propanoic acid, all right? And as the word prop suggests, it has three carbons in the acid. So three carbons, and there you go with your acid functional group. Keep adding hydrogen to them unless you fill up their valencies. Every carbon has 4 bonds in total. So there you go. This is your acid, and alcohol is different. We are actually going to work with methanol. So there you go. As the name meth suggests, it has only one carbon atom in the entire alcohol structure. There you go. You have a different alcohol and a different acid. Try forming an ester out of it. You're supposed to do two things. You're supposed to draw the entire structure of ester, and you're supposed to also come up with a name of the ester. All right. So now you're allowed to annotate. It's completely up to you whether you both do it on a piece of paper and then send it to me on WhatsApp, or you'd like to do it on my screen by annotating it on my screen. You're most welcome to do any. Let's get started.
I'll do it on the whiteboard if that's fine, but I might first write it down on the paper.
It's entirely up to you, whatever you like.
Okay.
I'm fine with both. So I'm gonna pause sharing for a little while, quick while, and I am going to share the recent picture that I took so that you have the entire series with you on WhatsApp. So I'm gonna quickly do that. There you go. I have resumed the sharing, and now you both have the picture that I just took. So you have the rules in front of you, both for drawing and naming of esters.